You see the problem statement? This one starting from the anti-balance equation to derive the. That's why I think the answer is that I showed in slide. We should derive from the anti-balance equation, fill in minus fill out, then plus generation rate equal to the solution rate.
Okay, from there I write the connection. I mean
you directly write the final answer. Actually, so that question asking you to about the whole duration process, right?
Okay.
This one is just now we have a y position put inside. The person was you didn't cite the calculation, right? That's only one side. Today is week 3.
You finish now participation 313. It's not
That's the reason why I
It's based on MU.
just claim again. We must go through the problem didn't very carefully, right? The problem asking you to study from the anti-balance equation, right? To derive the one-dimensional heat conduction equation along the L direction, right? The answer here, there's some problem. Okay. And the answer is exactly like this one. You know the reason why it's with but the software.
Cylinder.
The following question is exactly with the equation we're using to calculate, but we consider here. Exact same. All derivations set are exact same. Only difference is A. The A here is actually 2 pi r, right? Multiply L, that's the A here, right? But what is the A here? A here is constant, right? Small section, second area is constant. So that's why the formula has the whole derivation for step is almost exactly as this one. But when you derive here, doesn't matter it's the cylindrical shape or the rectangular shape, right? Because cross section area is A constant, right? Also, you can copy the whole slide. It's nothing different. The only difference we copy from here the final solution. Remember, here A is constant. That's equal to by R multiplied by L, right? That's the only difference. I don't have my answer here. I'm not sure why they have the side there because it doesn't appear differently on my computer. But as I mentioned, we study from the anti-balance equation, right? Very simple. Energy in material plus generation equals solution rate. Then remember, the only difference is A here. A here is constant. Then you can remove the A from the outside of the different operator, get the answer. It's not easy to recognize this slide. This one or this one. Basically, you see all the derivation process is exactly the same. Only difference is how the reflection of A. In here A is constant, right? But here A is equal to 2 pi r multiplied L, right? And what is A here? A equal to 4 pi r squared, right? That's the area of the spherical shell, right? The derivation, they are exactly the same, there's no difference, right? Okay, we'll go to question 3. Again, it's spherical coordinate, right? But what is interesting part, I will give a conclusion of the last question. We are starting for the one-dimensional heat conduction in Kelvin coordinate, whether along x, along y, along z. The impressions are exactly the same, right? The only difference is you change the impression from the indicator from x to y to z, right? Only difference, right? But in starting coordinate, like difference, we have heat conduction whether along the r direction, you have this one, right? That's the formula. But when you have heat conduction along the z direction, along the length, then impression you get exactly this one, right? Just change it from the x to z. So that's impression, right? Because the reason is because when you're choosing the control volume, we have constant cross-section area, right? That's the only difference. Of course, for three coordinate, we only have one length scale, right? Only along r. So that's the reason why. Okay, go to question 3. Again, cylindrical shape, right? We're using cylindrical coordinate. Give you the dimension, give you the height, give you the radius, right? LETEG here, give you
Oh,
a
it's
constant.
recording. Later Friday everyone download. Later people here, Richard 你一个人怕的不是？
Okay, isolate bound condition. Okay, commutative bound condition. One, what temperature bound condition for the short time?
明白了。
This question simple. They ask you, actually all you need to do is just do some translation work, right? Just translate the text to the mathematical expression, right? Basically all the same. Anyone here? Allow to translate.
No, I don't know correct.
Not correct, I'll have you to define that, okay?
No, turn out. Like that, you go there, you just put a blank paper. Yeah. You just don't let them give the face. Fuck you. You know, I heard from my friend, like, Richard, so first few we can do one. We can try out. You don't know, okay. First few we don't know what's going on. So they just ask fix the answer there.
So but this time I use
And the professor says, serious?
Yeah.
So
Look at all of
just
this.
say only this part of it, so I can answer this part. And this is the mistake, so I can answer this part. Yeah, so after that I'll calculate this part.
The K is constant, right? I mean, the conductivity K is constant, right? If you have constant conductivity, you should moving the K outside the differential operator, right? Go on. Roughly it's okay. Schematically roughly okay. So this question they just ask you to going from the common equation, right? General equation, three-dimensional rectangle heat conduction in the semiconductor, right? Just going to the general equation goes back to equation, right? You set it, then remove the term. Without generation, right? Remove the generation term. Because always symmetry, right? Symmetry remove the angle component, right? Constant material property can remove the K outside the differential operator, right? That's how we do, right?
But they didn't say it's constant.
Yeah, this is why it comes to the conductivity, right?
But the question here didn't write it's
They
constant.
didn't mention, that's what that matter.
So-
Because they don't require you to solving that, right?
Yes, correct. Yeah.
Just show that. Okay, they have generation here, right? Go on.
After that, we just use the boundary condition that z equals to 0 t.
About that, the only one.
Yeah.
Z equals to 0, t equals to 0. You mean t in Kelvin with 0 mean? Absolute 0.
Yeah, because of the insulated part. So
Isolation, right? Isolation means partial T, partial Z equals to 0, not the T equals 0. We don't have temperature equals 0, that means the minus 27, the 273, right? That's the trouble. You run, I think you help here. That's all right. Don't worry. That's one issue. That's our equation, right? Because when you determine how many boundary conditions is necessary to solving one unique solution, right? You know that's the formula, right? After you changing from the general equation to the special equation, that's the second order, right? Second order differential equation, right? Two variables, right? One variable is R, the other is Z. Both are second order. To get a unique solution, we need to do equation for each price, right? Total, we need a 4 bound condition. Otherwise, you don't get the one unique solution. So we need a 4 bound condition. We have now here K1, here the student partial T partial X equals 0 becomes 0 plus isolation and Z equals 0. So this one is right. Okay. Convection, this one is right. So what we have to do is right. We miss one, this one miss, right? Information. Because when you write down the special equation, special formula, right? You need to know how many boundary conditions we need to get one unique solution, right? If we miss one, then we must find where we miss that. If I go find them here and show you the right answer. It's okay to show the uncompleted answer is fine. But it might use have you to improve.
Okay, not bad, not bad.
Okay, this I guess is almost the send down, so just a schematic, right? The analytical coordinates, right? You have actually have three surfaces, right? Bottom, the top, the surrounding, and the axial, right? We're starting from the general equation, right? Three-dimensional with generation set 6 and not set 26, right? The dimension first is we know it's symmetry, right? So it's not changing temperature, not changing when the active component 5, right? Electron gun. Is that 6, the 20 term gun, partial T equals 0, right? Yes, it's 1. The dimension constant 人看到第几啊？
有少那个 automatic，
哦，没做了，
它
其实
bottom 是 isolated，所以 automatic，所以它的第一那个 increment 是 zero 的。
哦，这 dimension 的 constant 人看到第几啊？OK。那那它的 keep the key inside the differential equation, right? That's the thing. So get as I mentioned, how many bound conditions we need to get in one unique solution, depending on the first thing, the number of variable, right? How many independent variable have? Temperature is a function of R and Z, right? Two variables, right? How many order of differential? For R, we have second order differential, right? For Z, also second order differential. Doesn't mean for each get a unique solution we do integration twice, right? In total, we need to do integration 4 times. 4 times we reduce 4 unknown parameters, right? To get the magnitude of the unknown parameter, so we need to know 4 bound conditions. First thing about one thing, in this one, just the heat flux is 0 is fully allowed, right? Also, because it's 0, then that matter you can remove the minus k, right? The partial T partial x equals 0. You'll never encounter the T directly equals 0 because that's not going to happen, right? Another thing is, most likely you will neglect about the symmetrical bound condition, right? At the center line, at the axial, you always have the zero flux, right? Again, zero flux you directly, right? So the fully allowed all can remove the minus k, partial T, partial R equals 0 at the R equals 0, right? Same thing, very simple. But it's always easy to neglect the symmetrical bound condition, right? Because the problem statement usually don't give you, right? You should base on condition to derive the test, right? Simple. Next time, it's the same thing. We write down the symmetric equation, right? You derive from the general equation, goes to symmetric form equation. Then you just count how many bound conditions we need to get one solution. You miss one, go back, found one. If you have one extra one, definitely also do something wrong, right? You don't have extra bound condition. Because if you have just enough bound condition, you get one unique solution. But if you have one additional bound condition, that means what? They can match. If they can match, that doesn't make sense, right? If they didn't match, that means even the one unique solution cannot beat the last one. So that's it. Definitely, I have no solution, right? That thing also won't occur. So we need the right number of the bound condition, right? That's the thing. We need 4, there will be only 4. There won't be 5, there won't be 3. Okay, let's go to question 4. So, we have question 1, we're using Cartesian coordinate. Question 2 and 3, we're using string coordinate, right? Question 4, we're using the spherical coordinate, just the head seconds of that. Okay, metal ball, so that we can give you. This is transient term because I have to withdraw the ball from the oven, right? Put it in the cold air bins, right? Initial temperature give you one initial condition, right? Outside is cooling by the convection and radiation, right? Simple. Just here one tricky part because most likely they assume the T infinity equal to T surrounding, right? T infinity will calculate about the convection, right? T infinity, T surrounding will calculate about the radiation. Most likely they assume the same, but here and there are different, right?
这是我朋友说他的 FIP 是会，他每次玩一点去的。
Assume variable the canticle case is variable. Okay.
Thank you.
Again, just asking to press the mathematical formulation. Right. Again, going so just need you to going through from the general equation, go to specific equation, and write down the boundary condition, right? And each condition, because this is one you translate. Anyone else? Go.
问题。
三那个人对不对？
So you start with the normal the equation, then you see that there's no temperature change along the circumference. Yeah, so you only left with this one. Then this one is to the power of 2, then this is to the power of 1. So you just need 3 boundary conditions. Yeah, so the first one is
Not there, right? There's a
the heat loss is equal to the convection plus the radiation. And the second one is the geometric and thermal symmetry. And the third one is the initial boundary condition.
About the assumption, the last one is not assumption, just actually the condition in this case. Again, one condition refers to the length scale, the space, right? The constraint over time, we don't call it boundary condition, we call it initial condition. So abbreviation for the boundary condition in the exam from this type, just write EC, right? More than one ECS, right? Initial condition just write IC, right? Most likely you won't have more than one initial condition, just the IC. Choose an answer, basically, all the same thing. Just start from the equation, right? Because for second colleagues and also for third colleagues, most likely temperature not changing with the angular component, right? Always matching, right? So remove the angular component phi and theta, right? Have this one. Because you translate the right? Without relation, the system also gone. But the penalty here is not a constant, it's a variable, right? Then you show that, right? In here, we only have one unknown, right? One independent variable is R here, right? T is function of R, right? Second order differential, we need 2-bound condition, right? We only need the 2-bound condition. But for time, right? We only the first order differential, right? We need the 1 initial condition and 2-bound condition. That total will have 3, right? The first one is symmetry, the second one is just the continuity of heat flux, right? And heat flux by conduction equal to the combination of the convection and radiation, right? That's the Fourier law equal to the combination of Newton law and Stanford law, right? You get the impression and the 1 initial condition. To do that, you get the 1 unique solution. Because still a PDE, this course don't require you to solving the PDE because they need a higher level of mathematical skill, right? That's the reason we don't need to do that. But only very specified the PDE with very specific bound condition, you can get an analytical solution. Otherwise, most likely we are solving numerically, right? Cannot get an analytical solution. That's the reason why. No more information, guys. Yeah, sure. As I mentioned, wherever you apply the initial condition, both require 2 things: geometrically, symmetry, and the most symmetric. Very clearly here, right? Another thing I mentioned here, most likely in the exam, in the other problem, we encounter one thing is that you assume the T infinity equal to the surrounding, right? But if the problem statement giving you the 2 different temperature, you have to use 2 different temperature. Otherwise, it's one general assumption to assume the T infinity equal to T surrounding. But sometimes they are different. Okay, now we go to question 5. Again, question 5 is the 2-dimensional, okay. The rectangular shape, so we're using Cartesian coordinates. Dimension giving you, right, from the x from 0 to A, then y from 0 to B, right? We have 4 boundaries, right? They give you the 4-bound condition, right? The question asks you to write down the mathematical formula, just form the general equation, then try to reduce a few, remove a few items, right? To get a specific equation. Already see there are 4-bound conditions they give you directly. All you need to do is just translate, right? Translate from the text to mathematical equation, right? Very simple.
因为美国也不知道。要他会走。
不是我不会走，就我朋友不会走。我不要买新的他会走。Turning here, put your face cam.
So basically this is a two-dimensional. So the Cartesian equation is del t, del x and del t, del y. Since there's no heat energy generation and it's steady state, so the energy in the system is 0. Then for part 1 it says the surface at x equal to 0. The temperature is constant at Ts.
Because for two-dimensional, because we don't mention there anymore, so just x equal to 0 is fine.
So don't need mention the y.
Yeah, okay.
Then for the second part, the x equal to a at the boundary surface. Yeah, this is the
Okay. What's the second boundary condition? X equal to a, yeah, let's specify the heat flux. Go, you're right.
Then the third one, y equal to 0 for the convection is h t x,
Yeah. You don't need to mention about the equation. Don't need to mention the conics. Just the t minus t infinity is fine.
Okay. So for the last part is perfectly insulated and y equal to b is equal to 0.
Good. Only one thing. In exam, if you write your question, the answer like this one, you're missing like 20 to 30% of the credit because we ask you to starting from the general equation. You don't start from general equation. Directly say there is no generation, there is generation term. You directly write down the specification. You must starting from the question asks you starting from the general equation. You must starting from the very general equation, right? Then to review. Just show you my answer. It's almost the same, but yeah. It's more like standard. This is the standard answer. If you go to the quiz, you must. They have a very strict marking regime. To get a 4 credit, I know you have the capability of solving that perfectly. Then all you need is follow the standard approach, right? Because there is some skills during the examination, right? Schematic, roughly you didn't do, right? The question asking you to starting from general equation, just starting from general equation, right? So that's it. So particularly general equation, right? After you review for few items, they come to the material property, right? You get this one? Simple. Third state without continuation, right? Also it's two-dimensional because z doesn't matter, right? So we need a 4-1 condition, right? That's simple. One specific temperature, heat flux, then the convective bound condition, and the y equal to b, they have the isolation. Wherever you have isolation bound condition, you have minus k, partial t, partial x, partial t, partial y is 0, then you can remove the minus k, right? Because you equal to 0, doesn't matter you have the material property or not, right? That's the thing. Yes.
That's it.
Another thing, one thing, about this one, the second bound condition at here, remember the orientation, the heat flux, they have vector, they have direction, right? Heat flux, again here you should write down in terms of the, because this bound condition is from the surface energy equation, energy in, right, choosing small control surface here, right, energy by conduction, the minus k partial t partial x, right, and x equals a. But energy out is actually negative value, right? It's also energy in. There are two energy in, right? One energy in here by conduction, the other energy in by this one, 2s. This is why actually we have a negative side here because this q, because you have coordinate x point to this side, right? This direction, but the q point to this side, right? In negative value, that's why negative side here, right? Otherwise, when you derive, if you don't have negative side here, you derive, you actually get the reverse answer, right? That's the reason. You have once you have negative gradient, right? Later you derive again, the negative side will not be limited, right? Just for trouble, right? Okay, roughly the thing. Bound condition, actually, Because for the canonical equation, it's according to the box, or you apply the any condition for the box. But the outer bound condition actually is ruled out from the surface bounding equation, right? Therefore here, energy in, right, by two sides, energy in by conduction, energy in by this one, also energy in, right? So we have two energy in. That's why we remove the Q from the left side to the right side. We have next slide there. So that's the thing. Okay, just roughly continue today. Any question? Come here.
Yeah, so that's why you mentioned that we're missing that one part, right? But your answer so skip that part. Is it the E in minus E out equal to the E stationary? Is it?
Mean this one?
Yes, because you say that. I
This
mean,
one condition.
this question you say that we're missing something, so you will lose about 20% of the marks. Is the
Mean
starting?
this one.
Yes.
Starting because they didn't write down this first one, general equation. Directly go to the. They should remove the three item terms.
Yeah.
Yeah. You cancel, but if you write down the general equation, they cancel. Show a sign, you cancel that. But you cannot skip this part.
Okay. But you only write the E in minus E out that one, right?
That's not the matter because that's
Okay.
at least the one condition. That's fine.
Okay.
But this one, because they have the marking regime, right? So they say this part, 20 or 30% of the credit, right? You must have this part. Otherwise, you don't have credit for that, right? Because I do the marking, I know you have the capability of solving that. But some part, if you're missing, I cannot give you credit, right?
Everything close. The only thing is your grade. Grade shows drop already.
So that's something you won't like to occur because if something very simple question, right? You don't have the 4 marks, that's the trouble, right? Okay, understand? You got question, come here. You don't have question, you can go back. Okay. See you next week.